Hey, what's going on? It's Justin Dickmeyer from engineerintrainingexam.com, and in this video we will review elementary matrix operations. Elementary matrix operations play an important role in many matrix algebra applications, but most importantly in finding the inverse of a matrix and solving simultaneous linear equations discussed in this video. The first one is interchanging of two rows or columns. The second, multiplication of each element in a row or column by a non-zero number. And last, multiplication of a row or column by a non-zero number and add the result to another row or column. Now, when these operations are performed on a row, they are called elementary row operations. And when they're performed on columns, they are called elementary column operations. Now, before we start, it's important to define what an identity matrix is. An identity matrix is simply an n by n matrix, so a square matrix with 1 in the diagonals and 0 elsewhere. So an identity matrix would look something like this. Say a 2 by 2 matrix. This is an identity matrix where we have 1 in the diagonal and 0 elsewhere. Now if we're looking at a 3 by 3, it would look something like this. 1 in the diagonals and 0 elsewhere. So those are identity matrices. Now each type of elementary operation may be performed using matrix multiplication, using square matrices called elementary operators. Now if you guys need a refresher on matrix multiplication, don't hesitate to jump on over to that video review. It should be on the main page of the video page. Now to explain how these operations are done, it is best to run through a few examples. So let's start out with elementary row operations. So elementary row operations will be our first focus of this video review. Now to perform an elementary row operation on a certain matrix A, say we have a matrix A, and matrix A is a R by C matrix, the following steps are completed. Number 1, we need to find E. We need to find E. E is known as the elementary row operator, and we find E by applying the desired operation to an R by R identity matrix. So however many rows are in the matrix A, then we want to apply the desired operation to a R by R identity matrix. So number 2, once we define E, we need to carry out the operation by pre-multiplying A by E. So once we find A, we need to carry out operation by pre-multiplying A by E. So now that we've defined it, let's look at an example. This would probably help you guys better understand it. Let's say that we have a 3 by 2 matrix, and the matrix has elements 0, 1, 2, 3, 4, 5. Now we are asked to interchange the second and third rows. So the operation that we're asked to do is to interchange second and third rows. So using elementary matrix operations, let's do this operation. The first thing we must do is to create the elementary operator E. Remember, we need to find E. This is done by first creating an R by R matrix. So in this case, we have 3 rows. So our identity matrix is going to be a 3 by 3 identity matrix. That's simply illustrated like this. So we have to first create this R by R identity matrix and complete the operation on it. So our operation is interchange the second and third rows. So this is our identity matrix. Let's go ahead and interchange the second and third rows. So 1, 0, 0, the first row remains the same. Now we need to just flip these 2 rows. So our second row will now be 0, 0, 1, and our last row will be 0, 1, 0. So this is E. We just found E. So once we define E, we need to pre-multiply the matrix A, or the matrix we're given, by E. So this is how that would look. If we pre-multiply, that means that E will be in front of A, and that matrix is 1, 0, 0, 0, 0, 1, 0, 1, 0. And matrix A is 0, 1, 2, 3, 4, 5. Now all we need to do is carry out the matrix multiplication here. So we got, let's do this first element here. 1 times 0, 1 times 0, plus 0 times 2, plus 0 times 4. Now our second element here will be 1 times 1, plus 0 times 3, plus 0 times 5. So you guys know how to do matrix multiplication. You just carry that out, and we'll end up having the new matrix 0, 1, 4, 5, 2, 3. So visually you can confirm that indeed we switched out, interchanged the second and third rows by using elementary row operation. So let's look at another example here. Suppose we are asked to multiply each element of a 2 by 3 matrix A by 7. So our operation we want to carry out is to multiply each element in the second row by 7. So that's our operation. Now we also need to define our matrix. Say we're given the matrix 0, 1, 2, 3, 4, 5. So once again, we want to first find E. So to find E, we need to do the operation to a R by R identity matrix. So our identity matrix, there's 2 rows, is going to be a 2 by 2 identity matrix, which is 1, 1, 0, 0, simply that. So this is our identity matrix. Now we need to carry out the operation on this identity matrix. So we need to multiply each element in the second row by 7. So our new matrix will be 1, 0, 0, 7. And that is our elementary row operator E. Now our second step is to pre-multiply A by E. So E once again is 1, 0, 0, 7. And A is 0, 1, 2, 3, 4, 5. So once again, we just need to complete our matrix multiplication, which is routine for us now. We got 1 times 0, plus 0 times 3 for our first element. Our second element in the top row is 1 times 1 plus 0 times 4. And our third element in the top row is 1 times 2 plus 0 times 5. And once again, you guys can carry out the remainder elements to determine that we get a matrix of 0, 1, 2, 21, 28, 35. So once again, you can just quickly confirm that our operation of multiplying each element in the second row by 7 has been completed by looking at our original matrix and our new matrix. Now let's look at one more example. Let's look at what happens when we're asked to do a elementary row operation multiplying one row and adding the result of that row to another row. So let's say we're given a 2 by 2 matrix A with the elements 0, 1, 2, 3. And say we want to multiply each element in the first row by 3, and we want to add that result to the second row of A. So our operation that we wish to complete, our operation is to multiply each element in the first row by 3 and add result to the second row. And now that's the operation we want to complete on matrix A. So once again, our first step is, that's right, find E, the elementary row operator. So we have two rows here because since we're doing row operators, we need an R by R identity matrix. So it's going to be a 2 by 2 identity matrix, 1 in the diagonals, 0 elsewhere. So that's I. Now to determine our elementary row operator, we need to complete the operation on this identity matrix. So we need to multiply the first row by 3. So that would be 3 times 1 and 3 times 0. So just in our head, we know that we need to add 3 to the second row and 0 to the second row. So our elementary row operator is going to be 1, 0, 3, 1. So now we've completed that operation on the identity matrix, and now we have our elementary row operator. So now our second step is to pre-multiply A by E. So we got E as 1, 0, 3, 1, and we have A as 0, 1, 2, 3. So once again, matrix multiplication, 1 times 0 plus 0 times 2 is our first element. Our second element in the top row, our first row, is 1 times 1 plus 0 times 3. And I will let you guys carry out the final two elements on the second row, and we will find that our answer, or the new matrix, is going to be 0, 1, 2, 6. So now you can see that what we did is we multiplied the first row by 3 and added that result to the second row, and you can just confirm that once again just by visualizing. Now these were all simple examples of how to carry out elementary row matrix operations, row operations at that, and these are the basic process and the fundamental process, so you can carry them out on more complex matrices further like when you complete the inverse of a matrix, or look to complete or solve simultaneous linear equations using matrices. So before we close out, let's really quickly look at elementary column operations. So elementary column operations. Now, to perform an elementary column operation on a certain matrix A, which is still an R by C matrix, the following steps are completed. Number one is the same. We need to find E. Now, E in this case is known as the elementary column operator, whereas before when we were doing elementary row operators, E was known as the elementary row operator. Now, here's the difference when we're dealing with elementary column operations, is that we're finding E by applying the desired operation to a C by C identity matrix. So now we're dealing with columns, so our identity matrix is going to be a C by C identity matrix as opposed to an R by R in row operation. So we need to apply operation to C by C identity matrix. So once we find E, we need to carry out the elementary column operation by post-multiplying A by E. So whereas in row operations we were pre-multiplying A by E, now we are post-multiplying. So we need to post-multiply A by E. Post-multiply and C by C are differentiators in column operations versus elementary row operations. Now carrying out the actual procedures are identical in the fact that we still do matrix multiplication. It's just a little bit different of how we arrive at getting that final answer. So let's run through a quick example here. Let's just say that we have a 3 by 2 matrix and are asked to interchange the first and second columns. So let's say we have a matrix A, 0, 1, 2, 3, 4, 5. So our operation that we want to carry out is we want to interchange. We want to interchange the first and second columns. So our first step is to find E. So to find E, we need to apply our operation to a 2 by 2 identity matrix. See that we have two columns here, 1, 2, and we're looking at a C by C identity matrix. So a 2 by 2 ID matrix is 1 in the diagonals, 0 elsewhere. And now all we need to do is apply our desired operation, which is interchange the first and second columns. So our elementary column operator is now going to be 0, 1, 1, 0. Now that we have E, we need to post-multiply A by E to complete our operation and get our new matrix. So we need to post-multiply A by E. So we know A is 0, 1, 2, 3, 4, 5, and E is 0, 1, 1, 0. So just carrying out our matrix multiplication, we got 0 times 0 plus 1 times 1 is our first upper left element in the first row. Now our second element in the top row is 0 times 1 plus 1 times 0. And I'll let you guys carry out the remainder of the matrix multiplication. And what you want to finish off with is a new matrix, 1 0 3 2 5 4. So that's our new matrix, and that's we just performed it. We just interchanged the first and second columns of matrix A to get that new matrix, and you can confirm that real quick by just visualizing our matrix, our original matrix A. So once again, that was the basics of elementary matrix operations and how they're carried out. They were simple examples, but all I wanted to do was illustrate the process. Now, even on more complex matrices, the process remains the same. So just carry it out as you would. Don't be scared if the operations get a little bit more complex. So that's it for now, guys. Appreciate you checking out this video. Hop on over to engineeringtrainingexam.com and sign up for the free EIT preparation boot camp. Get yourself started on the right direction in preparing for this exam. And while you're at it, shoot me an email if you guys have any questions, comments, concerns, suggestions, feedback, anything. I really love hearing from you guys and enjoy helping you along the way. So if there's anything I can do, go ahead and get a hold of me. So that's it for now. Talk to you guys soon. All right, take care. Bye.